In this video, we're going to talk about what congruent triangles are and how to prove triangles congruent. So in this example that I have here, I have four different pairs of shapes, and we need to figure out which ones are not congruent. So feel free to pause the video while you determine which of the figures here are not congruent and try to answer why they're not congruent as well. So as we take a look at the first pair of rectangles over here, we'll see that they are congruent. So I'm going to write, yes, they are congruent. Notice how all of their sides and angles are exactly the same. And over here, this one's a little bit tricky. But if I redraw this triangle over here to be standing right side up the same way as this one, the 9 would be here, the 12 would be here, and the 5 would be here. So these two triangles are actually not congruent to each other because the sides that are in the same spots as each other are not the same. The corresponding sides are not the same. Over here, all of the sides and angles are the same measurement in the two different pentagons that we have here. So they are congruent to each other. And over here, all of the angles and the sides are congruent as well. So these two right triangles are in fact congruent to each other. From these examples, we can kind of figure out what it means for two objects to be congruent and to be not congruent. And when we're talking about triangles, two triangles are congruent when all of their corresponding sides are the same length and all of their corresponding angles are the same measure. In other words, they are exactly the same size and shape. So over here, I have two triangles, and we're told that they're congruent to each other. We're going to identify what the corresponding sides and angles are of the two congruent triangles. So AB is on the left of this triangle, and DE is also on the left of this triangle. Since they're in the same spot or the same position on the two different triangles, they correspond to each other. So I know that since the triangles are congruent, those corresponding sides would be congruent as well. You can also use the letters in the triangle names to figure out where the corresponding parts are. For example, AC is the first and last letters in the first triangle name, so it would correspond to the first and last letters, which is DF, in the second triangle name. So I'm going to put that here. AC is congruent to DF. And then finally, oops, I should make these look a little bit different from each other. And then finally, BC is congruent to EF. So we've named all of the corresponding sides of the two triangles. Now moving on to the corresponding angles. We have angle A and angle D. We have angle B and angle E. And we have angle C and angle F. So it's a lot of work to show triangles are congruent if you have to show that all three pairs of corresponding sides and all three corresponding pairs of angles are congruent to each other. That would be 6 pairs of things that you would have to show are congruent between the two triangles. So luckily, even though all of this stuff is true whenever we have congruent triangles, luckily we have some shortcuts for helping us prove triangles are congruent that allow us to not have to prove all of these things every single time about every single triangle that we encounter to know that it's congruent. Here are our first 3 methods for proving triangles congruent, our first 3 shortcuts. There are a total of 5. The first 3 that we're going to talk about in this video are SSS, which is side, 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 SAS, which is side, angle, side, and ASA, which is angle, side, angle. SSS means that all 3 pairs of corresponding sides between the two triangles are congruent to each other. SAS means that there are 2 pairs of congruent corresponding sides with a congruent included angle. An included angle means that the angle is directly in between the 2 congruent sides. The order of the letters does matter, and just like in the name SAS, how the A is in between the 2 S's, that needs to be true of the information that we see in the triangle as well. Notice here how we have our 2 sides. with the angle directly in between those two congruent sides. ASA is angle side angle, where we have two congruent pairs of angles with a congruent included side. That means a side in between the two angles. And notice here how just like the order of the letters, the S, the side, comes directly in between the two A's, the two angles. What we're going to do here is we're going to mark each diagram with the given information, and we're going to determine which method proves each of the triangles congruent. Feel free to pause your video to try it yourself first. So over here, we have angle A is congruent to angle D. We have angle B is congruent to angle E. And we have AB is congruent to DE. So what we have here is ASA. We have two congruent pairs of angles with a congruent side in between. Angle, side, angle, angle, side, angle. So these two triangles are congruent by ASA. Over here in the next example, we have WX congruent to XY. We have WZ congruent to ZY. And we have XZ congruent to itself. Even if they didn't tell us that XZ was congruent to itself, we would know that because it's shared between the two triangles, between the left hand and the right hand triangle. And when something's shared, we know it's congruent to itself by the reflexive property. So always look out for shared sides between triangles. It comes up a lot, and it gives you a side that you know is congruent to itself. So it's really, really nice when we have that shared side. So here we have SSS. We have 1, 2, and the shared side, 3 pairs of congruent corresponding sides between the two triangles here. Moving on, we have RS is congruent to TS. We have angle QSR congruent to angle TSU. And that was given here, but even if it wasn't, we know these are vertical angles. Remember, anytime you have intersecting lines that you see that letter X, you have congruent vertical angles. So vertical angles are always congruent. So even if they didn't tell us that, we would know those vertical angles are congruent. And they also tell us that QS is congruent to US. So what we have here is SAS. We have two sides that are congruent in the two triangles with a congruent angle in between. Side, angle, side, side, angle, side. Okay, for this first one, we're going to say what else is needed to know the triangles are congruent by SAS. In this first example, we have a side and an angle. In order to be SAS, the side would have to come directly after the angle because the angle needs to be directly in between the two sides. Side, angle, side, side, angle, side. So the information that was missing here to make side, angle, side, oops, I wrote it incorrectly, is JI congruent to TS. Over here in this next one, we need a side and an angle because we already have one side. We could use our vertical angles. And then let's say we have information about these two sides. That would make side, angle, side. So I'm going to put down additional angle, additional information that could prove the triangles congruent by SAS are these two angles and these two sides. That would make side, angle, side, side, angle, side. So once again, in these examples, we're just making up additional information that would make the triangles congruent by SAS. Next one, which are congruent by SSS, by side, side, side? Obviously, this first one. There are 3 pairs of congruent corresponding sides. Not this one. There's only 2 pairs of congruent corresponding sides. We don't know anything about these 2 sides. We have vertical angles, but that gives you an angle, not a side. So I'm going to put down here, no. These are not congruent by side, angle, side, by side, side, side. By side, angle, side, yes, but not by side, side, side. Over here, I'm going to put no. All we have is one side on each of these triangles that's congruent to each other. You do have the angles, the right angles, and you do have vertical angles. So that would be ASA. That would not be side, side, side. And over here, yes, these are congruent by SSS. We have the two pairs of congruent corresponding sides from the givens, and then we also have the shared side. That's congruent to itself by the reflexive property. So we have three pairs of congruent corresponding sides. And here, three statements that would make the triangles congruent by ASA. So they already give us angle Q congruent to angle M. I have a lot of options, but I'm just going to do this for ASA. I'm going to do QP congruent to MN, and I'm going to do angle P congruent to angle N, and that's ASA. Once again, not the only option. Here we were just making up any two pieces of information that would make the triangles congruent by ASA. Okay. In this first one, we have AD congruent to DC, and we're told BD bisects angle ADC. If angle ADC is being bisected, that means it's being cut into two congruent parts. Let me do that a little bit better. Okay, and then we have the shared side between the two triangles. That's reflexive property. So we have side, angle, side, side, angle, side. So these triangles are congruent by SAS. Over here in number 2, we have angle B congruent to angle D. We have these alternate interior angles that are congruent. So since we have congruent alternate interior angles, if we wanted to, we could say that these lines are parallel. I don't think we're going to need it here, but just keep in mind, congruent alternate interior angles means that lines are parallel. Okay, we know that C is the midpoint of BD, and we also know that vertical angles are always congruent. So here, these triangles are congruent by ASA. And finally, AD congruent to DC. BD is bisecting line segment AC, so line segment AC is being cut into two equal parts. And then we have the shared side, which is congruent to itself by reflexive property. So these two triangles are congruent by SSS. Moving on to our fourth method for proving triangles congruent, we have angle, angle, side. And it's very, very similar to angle, side, angle, except the information is going to appear in a different order. Instead of the side being directly in between the two angles, for angle, angle, side, the side is going to follow the two congruent angles. So for example, say I knew that these two angles are congruent and that these two angles are congruent. My congruent side would either have to be here or here. Angle, angle, side, or angle, angle, side. I'll just make it here. So once again, angle, angle, side, angle, angle, side. So see how the side is not in between the two angles. The side comes after the two congruent angles. And I should make these two angles look different than the other pair of congruent angles. They might not be the same as each other. And then our fifth and final method for proving triangles congruent is hypotenuse leg, or HL for short. And hypotenuse leg is a very special one because it only applies to right triangles. And you can remember that because you only have a hypotenuse and legs of right triangles. Those are the names of the sides of specifically right triangles. So remember that the hypotenuse is the longest part of the right triangle, and you can always locate it because it is opposite from the right angle. And the other two sides of a right triangle are just called legs. Both of them are called legs. So to have HL, the very first thing you need is right triangles in order for it to even be a possibility. Once you know that you have right triangles, all you need after that is an H and an L. You need congruent hypotenuses, that's the H part, and you need one pair of congruent legs, that's the L part. You don't need both pairs of legs to be congruent, just one is enough. And take a look at this note over here. This is not SSA. In a couple of minutes, we'll talk about why SSA is not a valid method. So even though it kind of looks like SSA, it's really not because it's specifically for a right triangle. HL is for specifically right triangles. Okay, Over here, let's take a look and let's see if we have enough information to prove each of the triangles congruent. So here we have a shared side between the two triangles, so it's congruent to itself. And what we have here is we actually have HL because we have right triangles. AC and BD are the hypotenuses and they're congruent. And then we have one pair of congruent legs, CB congruent to itself. Over here, we have two parallel sides of these two triangles. When we have parallel lines, alternate interior angles are congruent. If you're having trouble seeing those, just highlight your parallel lines and the transversal intersecting them, and you'll see your letter Z. In the corners of the Z are your alternate interior angles. And we have vertical angles, which are always congruent. And the only other thing we have is another pair of alternate interior angles. We don't have these sides. AAA is not a valid method of proving triangles congruent. So no, the triangles are not congruent here because we don't have a side. All of the methods include a side. Over here, we have a shared side. So we have SSS. We have all three pairs of corresponding sides are congruent to each other. Okay, up here, we're taking a look at this triangle and this triangle. We have a pair of sides and we have a pair of angles. These are right angles, so HL comes to mind, but we don't know anything about the hypotenuses. We might be thinking maybe this is SAS, but I don't know anything about these sides. You might be thinking maybe it's AAS, but we don't know anything about these angles. So we only have one A and one S, and that is not enough information. Right here, no, these triangles are not congruent. We don't have enough information so far. Here we have SAS, and over here we have some overlapping triangles. You'll learn about those more later on, but a good strategy is to draw each one of them separately. So I'm just going to take them apart really quickly. And draw them separately from each other. And I'm just going to mark them exactly the way that they're marked in the diagram. And now that I've separated them, I can see that we have angle, angle, side. Now that I've marked the information from the diagram. So when you have triangles that are on top of each other, sometimes it's helpful to color code them and redraw them separately. And that's something you'll see a lot going forward in the next couple of weeks in class. Okay, here I have an example of two triangles that are formed from two congruent sides followed by a congruent angle. And you can see that these triangles are not the same size. SSA does not always prove triangles congruent. And if it doesn't work in every single situation, then we can't use it to prove triangles congruent because it's not always true. It doesn't always make congruent triangles. You can also remember that SSA doesn't work because if you write it backwards, it is a very not nice word that you don't want to be writing on your geometry test. So SSA is not a valid method for proving triangles congruent. Even if you have the information for it, you can't use it to prove triangles congruent. It doesn't always work. And then we have AAA, and AAA also does not always make congruent triangles. Here, I'm giving you two equilateral triangles. And since these triangles are equilateral, they have 60-degree angles because all equilateral triangles have three equal angles, which all measure 60 degrees. But notice how this triangle is larger than this one. So the sides are not the same. They're not congruent. They're not exactly the same size. So even though they have congruent angles, any two equilateral triangles don't always have to be congruent to each other. So that's an example of a time where AA or AAA does not make congruent triangles. So AA or AAA does not work. And over here, we're just going to end with a short proof. And then I'm going to put a summary of all the 5 methods that we saw in this video so far. So we have angle ADC and BDC are right angles. I'm going to mark that in the diagram. And we have that AC is congruent to BC. And we want to prove that the two triangles are congruent to each other. It's missing the proof statement, so I'm going to put it down here. We want to prove that triangle ADC is congruent to triangle BDC. So before we start writing our proof, let's come up with our plan. We already have the two congruent right angles. That's an angle we can use. And we already have a pair of congruent sides, AC and BC. And I see also the shared side between the two triangles. And that's another side we can use because it's congruent to itself by reflexive property. But if I go around the triangle, I have side angle, or SSA, side angle, or SSA. If you go the reverse way, you have ASS. Same thing as SSA. SSA is not a valid method of proving triangles congruent. So I remember that I do have right triangles here. And I do have a special method that only works for right triangles, HL. So maybe it'll work here. I do have right triangles. Let's check that I have the H. I do have congruent hypotenuses. And let's check that I have the L. I do have a pair of congruent legs. It doesn't matter if it's this leg or this leg. It doesn't matter as long as it's one pair, which we do have. So we are going to be using HL here. So even if you don't know the rest of the proof, you can use your information in order to figure out how you're ultimately going to be proving the triangle's congruent. And your reason for proving the triangle's congruent is always going to be one of our 5 shortcuts, because that's how you know they're congruent. If one of those 5 shortcuts that we learned about, the 5 methods that we learned about, applies. Our givens are angle ADC and angle BDC are right angles. And we're also given that AC is congruent to BC. So that's my given. Then it tells us that triangles ADC and triangles BDC are right triangles. And in order to use HL, you do need to know that you have right triangles. So this is a necessary step in the proof. We do need to actually state that the triangles are right triangles in order to use HL, since it's only for right triangles. So I'm going to write here a triangle with a right angle is a right triangle. And we already established that there are right angles here because that was given to us. Okay, now we need the rest of the information that we need for HL. So I see a reflexive postulate here. So that is DC, congruent to DC. So that's the leg that we're using. The H was already from our givens, and we did already state that we have right triangles, so we don't need this step of the proof. We have everything that we need for HL. Our given was the H and the right angles. We stated that we have right triangles to use HL. We mentioned the leg with the reflexive property, so we have everything we need to say the triangles are congruent by HL. Here is just a summary of the 5 methods. Feel free to pause the video because I'm going to end it now, so that way you can take a photo of this or write it down.